Good morning, everyone. Please welcome back your ISEF host, Barb Baker.
Hello again, everyone. Good morning. And welcome to our Tuesday morning programs, the Excellence in Science and Technology panel and the Innovation, Entrepreneurship, and Impact panel. During today's sessions, you'll be hearing from several distinguished guests, prominent STEM leaders, society alumni, and groundbreaking innovators, each of whom is joining us today because they share a passion for nurturing the next generation of young scientists and engineers. Several of the panelists you'll see on stage today will also be available for a short selfie and autograph session outside Hall A immediately following our last panel. So be sure to stop by and say hello. First up is the Excellence in Science and Technology panel presented by Aramco. Let's find out more about Aramco right now.
They say that humanity's reach should exceed its grasp. That even in moments of uncertainty or crisis, the determination to strive towards a brighter future is what defines the best of us. This vision, this pioneering spirit, is what powers us at Aramco. Whether pushing boundaries in the quest for greater fuel efficiency, or seeking ways for us to live in harmony with the planet, the same determination that drives an athlete to compete is what drives us to seek perfection. From the young minds who are building our future, to the deal makers providing energy to the world, and the scientists exploring new frontiers in search of limitless possibilities. These pioneers ask not just why, or when, or who, but how. How can we find solutions to protect our world, yet use its resources to drive economies and fulfill our dreams? How do we leverage our position at the heart of the industry to make a positive change across the world? How can we embrace new technologies to forge new roads ahead? Answering such important questions is never easy. And there comes a time in all our lives when we're faced with something seemingly insurmountable. A chasm so wide, with no apparent way across. A responsibility so immense that everything comes under question. But it's in those moments that we see our humanity. And step by step, turn by turn, we will move forward as we embrace our limitless capacity to grow. By striving to share expertise, working hand in hand with partners, promoting mutual understanding, and by encouraging enterprise and education and ambition. This commitment, always to ask how, this is what powers us at Aramco. And in our uncertain world, this is the leadership you can expect from the energy provider that the world depends on. A place where science meets imagination, where actions follow promises, where dreams become reality. Aramco, powered by How.
Congratulations, ISEF, on 75 years of positive impact, and to all the 2025 finalists. And our thanks to Aramco for their support of today's Excellence in Science and Technology panel. And before we get started, a quick reminder to those of you presenting questions to the panel. Make sure you step right up to the microphone in the center aisle when you are called. Everyone see it over here? Step right over to there. Now please, welcome our moderator, science correspondent and longtime friend of ISEF, Joe Palca, joined by our esteemed Excellence in Science and Technology panel.
Hello, everyone. That's a great film. I think we're just going to show that again and again and again. That would be fun. I'm Joe Palca. I used to be a science correspondent. I am now a former science correspondent, but it's almost the same thing. Let me introduce this panel. It's very distinguished, interesting folks. To my immediate left is Martin Chalfie. He's the university professor and Department of Biological Sciences at Columbia University. Columbia University. Go Lions. Society for Science Honorary Board, Chairman of the Committee on Human Rights at the U.S. National Academy of Sciences, and the 2008 winner of some prize or other. Tina Henkin is Distinguished University Professor Emeritus, the Department of Microbiology at The Ohio State University. Umit Ozkan is Distinguished University Professor, Chemical and Biomolecular Engineering, Department Chair at The Ohio State University. And finally, K Shum, Professor and Distinguished University Scholar, Division of Geodetic Science at School of Earth Sciences. Ooh, that's interesting, The Ohio State University. And also a Nobel Peace Prize contributor in 2007. So what we're going to do is we have students here who have submitted questions, and they've been carefully selected, and they will come to the microphone and ask a question, and we will discuss their question and go on to the next. So why don't we start with, I think Cooper's first. Go ahead. Say your name and where you're from, Cooper.
Hello, my name's Cooper, and I'm from Connecticut. And my question is for Dr. Umit Ozkan. As a leader in catalysis and sustainable energy research, what do you see as the most promising advancements in renewable energy technology in the next decade? Thank you.
I guess it's already assigned to me. So that's a great question. Thank you for that. I see a lot of potential in electrochemistry and electrocatalysis. In other words, using electrons to drive reactions that wouldn't normally go forward. And I will make it a little broader than just the energy. Chemical manufacturing can really be revolutionized by using electrochemistry and electrocatalysis. Again, we need to get the electrons from a renewable source, such as wind or solar or even nuclear energy. But once we have the electrons, we can use them to drive many reactions which normally wouldn't go forward. An example is ammonia production. We need ammonia for making fertilizers. That's how we feed the world population. Ammonia is produced through a well-known process called Haber-Bosch process, and it's a well-established technology, high pressure, high temperature, very energy intensive, uses fossil fuel for making hydrogen. We can make ammonia using electrocatalysis, just using water and nitrogen. It can be modular, it can be small scale, it can be where we need it. So that's just one example of what electrochemistry and electrocatalysis can do.
Excellent. Let's have the next question then.
Hi, my name is Nachime Anamale, and I'm from North Carolina, USA. My question is for Dr. Martin Chalfie. So the discovery of GFP revolutionized biological imaging. If you were beginning your career today, what emerging field or technology would you be most excited to explore?
And Marty, before you get started, tell everyone, does everyone know what GFP is? Show of hands. Okay, then you have to explain what GFP is, and then you can answer the question.
GFP stands for green fluorescent protein, and because it's a protein that is completely encoded by DNA, we can put this in any organism, and if the organism expresses that, it can make the protein, and we can see the protein in the cells that express it simply by shining blue light on it, and we see green. So you can watch things happen in living cells, and thousands of people have used this and other fluorescent proteins as a way of looking at biology. It's an interesting question, the question of what are you most excited about? When I walk around and look at the exhibits here, I'm excited about everything. I think we do, I'm going to interpret the question in a slightly different way. It's sort of asking, what should I work on? What's the exciting thing that I should be working on? And I don't think that's the right question. One of the things that I think adults do to children, high school students, college students that they're very excited about because they see their potential is they say to them, follow your passion. Now, if anyone said that to me, I'd be scared to death. And I would just say to myself, wait, what's my passion? I don't want to make a mistake. So I think that phrase is really wrong. It really doesn't make any difference what you work on because everything's going to change and you're going to get different interests all the time. They're all going to change. I think the phrase we should be saying is not follow your passion, but whatever you do, be passionate, be involved, be committed to what it is. Doesn't make any difference, really, because you're going to find something spectacular.
I'm not going to ask for a rebuttal. That was. Go ahead.
Hello, my name is Gwen Rodriguez, and I'm from El Paso, Texas. My question is for Dr. K Shum. We are seeing an increased need for GPS and satellite technology for climate monitoring. What are the biggest challenges in geodetic science today, and what do you recommend for young scientists to help solve these challenges?
Thank you very much for the question. First of all, I really appreciate seeing some of your work. Although it's very little time, it really excites me. And to be honest, I never seen so many high school students with their invention or their poster, their study in the same gathering. So to answer the question, there was GPS mentioned, which is Global Positioning System. I want to say that there are many satellite observations, and some of them we call it geodetic observations, meaning that you actually need to know the size, maybe the length unit, so measuring sea level changes, measuring groundwater changes, measuring flood, and so on. So in addition to GPS, internationally it's called GNSS, Global Navigational System, satellite systems. So this is like a multinational system. The GPS is not only for navigation, it could do, the question is that whether it could do sensing climate change. Absolutely, there's a whole lot of work being done. Meaning, let me give you an example. So it's radar signal. The radar signal actually could bounce off some ocean, some soil, and then if you correct it, the signal is very weak. It's actually called signal of opportunity, meaning that you don't have to pay for it. And if you can gather it, you could interpret the earth, the flood, the drought, and so on. So there's a whole, let me sort of articulate also Martin's thing. I really believe that your inventions, your focus, what you wanted to do, and then you find tools. Some of the tools could be satellite observations, geodetic observation, GPS, and so on. So I really, it's my honor to be here. Thank you.
And I would just add to that, as a former journalist, that, well, it's current journalist, that it's very important to be good at explaining what you're interested in and what you do. Because I think it's clear that there's a broad public out there that would be more enthusiastic about science if they knew just how cool it is. And you guys have already figured that out. But be sure to share that with others. Yes, go ahead.
Hi, my name is Yemi Laiton from Sydney, Australia. My question is for Dr. Tina Henkin. Given your work in understanding bacterial RNA, what advancements do you believe are most likely to revolutionize our approach to antibiotic resistance in the near future?
Thank you. That's a great question. I think that there's two major pathways that we need to follow in terms of identifying new antibiotics. Historically, most of the antibiotics that we've identified over the years have been isolated as natural products from organisms that have been isolated from the soil or somewhere like that. And the big limitation in that is that we can only culture, we can only grow something like 1% of the organisms that we now know are out there. So the big technical advance that has come is our ability to take samples from nature and sequence all of the DNA and figure out from that DNA using bioinformatics all of the different organisms that are in there, even if we can't grow them, and identify pathways for antibiotic biosynthesis in those organisms. And again, even if we can't isolate the organism, can't grow it, we can take the genes, put them into organisms that we can work with, and generate new antibiotics that way. The second major pathway is identifying new targets. So instead of just relying on whatever Mother Nature has identified as places that antibiotics can be directed to, we can use information and structural information about organisms that we generate from basic science research, and then use that and our new abilities to model those structures and model molecules that might interact with those structures, and then design chemicals that can target those. So I think that those are the two major approaches that are being actively used to help us to come up with new antibiotics and combat antibiotic resistance.
Cool.
Hello, my name is Abril Esparza, and I am from Lexington Park, Maryland. My question is for anyone on the panel. What inspired you to begin pursuing your career path in science and technology? And what drives you to continue moving forward in this career? Thank you.
Do you want me to use the Marty approach?
I'll start.
Go ahead, Tina.
So I grew up in a very working class environment, and my family had very little money. And my impetus when I started college in going into science was simply that I was hoping I could get a job. And then I took my first courses in college, in particular in molecular biology, and discovered that this was not a job. This was going to be my life's work, because I got so excited about how things worked at the molecular level. And that then led me on my pathway throughout. And I think that's what's continued to drive my interest, just wanting to know how things work.
Umit, did you?
I grew up as the youngest daughter in a middle-class family in Turkey. I loved math, I loved chemistry, science, especially chemistry, and chemical engineering seemed like a good way of combining them. And I also wanted to teach. I wanted to do research, discover new things. So what drives me every day is working with incredibly talented young men and women, just like you are, every day, who are in my classes or in my laboratories. They motivate me, they inspire me, they keep me on my toes, they challenge me, and I keep learning every day. Every day I'm learning something new. And oftentimes I'm learning from my students, and that's extremely exciting. So that's what drives me, and I can't think of a better life than what I'm doing today.
Okay.
That's a great question. I grew up also very poor and immigrated from Hong Kong, and actually went to college in Texas. So my motivation was, at the time, I like to watch the skies, and astronomy would be my first love. And then I found out this thing called satellites that human could drive flying around the Earth. I said, that's fascinating. So I started learning a lot about that. And I have to come into this meeting, and also in the last few years, being a professor for a long time, I was actually involved in some entrepreneurial project funded by National Science Foundation. But the first thing they told me is that professors coming here cannot talk. Let your student talk. And then everybody, including the professor, has to learn basic business practice. So I learned this information about business canvas, pain points. It's really very eye-opening. So like Umit said, I have this passion that I'm very glad that I could learn almost every day from you and from my students, from my postdocs. Thank you.
You want me to talk?
Yes, please.
Okay. So I came from a family where my father didn't go to high school. My mother couldn't go to college because of the Depression. And I think you're sort of hearing from everybody on the panel something that I think puts a lie to something that's being said a lot, and that is that we're the elite. We don't come from the elite. I think science helps make everyone the elite, that we give people opportunities, and the more chance we have to do that, the better. I'm exceptionally grateful for the opportunities that I've gotten. I think my fellow panelists would probably agree as well. I had a horrible time. I was excited about science and math when I was a kid. I had one summer where I had a horrible idea. The horrible idea was true scientists never ask for help. I spent that whole summer trying to do an experiment. It failed every single time. At the end of the summer, that person in charge of the lab said to me, go home, rest, come back to school, and try the experiment one more time. And I did, and it failed again. And I quit science. I finished up my major. I graduated from college. I took a whole bunch of jobs, including teaching for 2 years at a high school. I made a discovery when I was teaching high school. Summer vacation is for the students. The teachers have to find a summer job. And I was really lucky. I was able to find a job in a laboratory working. And for the first time in my life, the experiment worked. And having an experiment work is so exciting that I actually thought, maybe I can do this. I will add one other thing. When I was inducted into the National Academy of Sciences, they have the most boring ceremony that you could ever imagine. A whole bunch of people, one at a time, get on the stage, and they have to sign a book, they have a picture taken. But someone says one sentence about that. And my wife and my, at the time, 12-year-old daughter was in the audience. And I thought, oh my God, my daughters had to sit through all of these people, one at a time, walking on the stage. And I went down to her after I was finished and I said, I want to apologize. You must be bored out of your mind. And my 12-year-old daughter looked at me, frankly, as she often looks at me, that like I'm the stupidest person on the planet, and says, Dad, don't you know about all of those people? And I said, oh, what do you mean? She had been listening to those sentences about what people had done. She said, Dad, every single person that walked across that stage was the first person in the world to see or do what they did. And that's one of those joys that we get. We get to be the first people to see something that no one else has seen, to do something that no one else has seen. And that brings an enormous amount of joy.
Absolutely.
I'm Benny Pang. I'm from Arizona, and this question is for all of you on the panel. How applicable are history, writing, English, ethics, languages, and other humanities to science careers? And also, are there any courses that high schoolers or college students that are planning on entering these science-related careers should really consider taking?
Yes.
I will tackle this question, which is a great question. I would say all of the above. Let's start with writing, and I want to make it even broader, not just writing, but communications. You may have the best and the brightest idea, but if you cannot communicate your ideas, it's no good. You have to be able to communicate your ideas. They may be difficult science concepts to the public so they understand what you're doing. Languages. Try to learn at least one other language besides your native tongue. That's how you get to know another culture. Without knowing the language, it's really difficult to get immersed in the culture. History, we have to learn history, otherwise we may make the same mistakes that our ancestors made. And humanities, we cannot really isolate science, humanities, social sciences, because science is really serving the public, serving the humanity, and we cannot really divorce those, isolate those. So I think it's really important to be well-rounded. So I would encourage all of you to take courses besides just sciences and really become well-rounded individuals who can speak to anybody and explain any concept, even if it's the most difficult scientific concept.
I just want to add one sort of note. To me, in college, the best courses I took that trained me to be a scientist were the humanities and social science courses because of the final exams. We'd read lots of papers and books and everything, but the final exams never asked us questions that had ever been asked in class before. They were completely new. I remember reading a bunch of novels by Dostoevsky, and the final exam was, talk about the role of the buffoon in Dostoevsky's novels. And you panicked and then realized that you had to take data from everywhere, all the things you had read, all the things you'd heard about, thought about, and synthesize it into something that was a reasonable answer if you were lucky. And I think that's what we do as scientists. We don't just sit there doing an experiment. We're constantly having inputs from reading, from hearing talks, from learning from other people that we're mixing and matching. So to me, it was really important as a way of thinking about things to have those inputs. Also, it's a lot of fun.
Okay, sure.
Hi, my name is Sadhika Aramili, and I'm from India. And my question is for everyone on the panel. My question is, if I ask ChatGPT or any other generative AI to write a research paper, it'll do so in less than a minute. How can we distinguish this AI-manufactured research from real, genuine, meaningful research? Thank you.
Tina, have you thought about this question?
I think Martin has an answer for that.
Yeah.
Okay.
Sorry. We're trying to avoid
The
me.
Marty,
on this one.
the Marty question, okay.
So when ChatGPT came out, I heard on the news, as all of you have, I'm sure, that students were going to use it to cheat on their essays. This seemed to be the main thing that people were concerned about. I put this down to the fact that most adults fear the next generation, but let's not get into that. But I decided to have an experiment. I asked ChatGPT, because my name is unique, to write a 1,000-word essay on my early childhood. It was spectacular. Every single bit in it was incorrect. It gave me a sister named Karen. I don't have a sister. It said things about my parents that were untrue, had my wrong birthday. It had everything wrong. And I loved it because I realized teachers shouldn't be worried about students writing essays using ChatGPT. They should give the essay question to ChatGPT. Have it write the essay and then give it to the students and say, fact check this. Find out what's wrong here. Figure this out. Think about what the problems are. So I think that's the thing. The one problem with, one good thing about all of this talk about AI is it gives a second opinion. It gives another way of thinking about it, but you have to decide on what that is. You also have to fact check. The problem, as I see it, is if people absolutely believe it without thinking about it, there can be real danger. I have a friend whose teenage son wrote an essay. She saw him write the essay, but the teacher put it into ChatGPT and asked, did ChatGPT write this? And since it's a large language model, it's going to answer one of two ways, yes or no. And half the essays it said yes, and half the essays it said no. So the teacher went to my friend and said, I found your child had cheated, because she believed what ChatGPT had said. And my friend, who had seen her son write this, knew that wasn't true. But just imagine, and they were able to clear this up, but just imagine a teacher or anyone in authority having that belief that whatever comes out is true, and the student saying to the teacher, I didn't write that. I didn't use ChatGPT. I wrote that for sure. The teacher would then say, not only do you cheat, you lied to me, because they believed the computer as opposed to believing the child. That could cause irreparable harm. So we have to check. Having it as an aid is terrific, but we have to always sort of verify. And this is what we do scientifically. We don't believe what a result is until we can reproduce it. Then we get alternate confirmation of things.
Yeah.
If I can
Yeah.
very quickly add something. I think it really speaks to even a broader issue, not just fact-checking what ChatGPT is offering us, but fact-checking everything that we see on social media, for example. If we all started questioning things, I think we will be much better as a society. I think accepting things at face value, whether it is something we see on social media or ChatGPT offers something, I think that's where we are really hurting ourselves. So that's very important. Question everything.
Tina, go ahead.
Well, I'll give another anecdote for ChatGPT in terms of teaching. My daughter just started this year as a faculty member in chemical engineering at University of Pennsylvania. And she gave her students an exercise of generating a poster on some topic. And fortunately, she generously gave them the opportunity to submit their poster ahead of time, and she would give feedback, and then they could fix it. Well, one of the ones that she got early, she immediately knew was generated by ChatGPT. And the reason she knew was that the figures were total gobbledygook. I mean, they looked beautiful, but the labels didn't make any sense, and they just didn't make any sense. The text was reasonable, but what she did is she sent it to her parents, who don't know anything about this topic, and said, tell me what you think about this poster. And we're trained as scientists, but we don't know this topic, and we looked at it, and we read the text, and it kind of made sense. And then she said, look at the figures. So it is recognizable. You have to be able to, as you've been hearing, evaluate what the content is. And you can learn more from evaluating that than just reading the poster or reading the material.
Good morning. My name is Ethan Chang, and I'm from Southern California. And my question is for anyone on the panel. Advancing science often requires collaboration across disciplines. How can young researchers effectively build cross-disciplinary networks to enhance their work? Thank you.
Why don't you start first?
Okay. Are we going to the Marty answer? Or does
No,
somebody-
no, we can, but
Go ahead, Marty. I shouldn't have given you guys the out.
So, one of the, so I'm going to react to the question, maybe not answer it directly. I often hear that it's important for developing scientists to build a network and be on social media or do things. And I'm too much of the old guard to know if that's really true or not. But I think that that's not really the important thing. The important thing is the experiment. As you do experiments, as you think, where should this go? It sort of naturally directs you to who is working on this, what do I need to know or learn or collaborate with to be able to answer this question? And I think people will find that others are really open, because if you're excited about something they're doing, they're going to be very excited about what you're doing as well. So I think there's sort of a natural flow, with the one qualification is don't be shy about it. People want to hear you. People want to talk with you. Don't feel that you have to be a professor to talk to other professors. One of the things I've found often in my lab is a student will come in and we'll be talking about something, and I won't know anything about it, but I know someone else in the department that knows something about it. And I'll say, oh, I don't know this, but go talk to so-and-so. And they usually are sort of shocked that I wanted them to go and do the talking. But once they do that, it changes how they interact. So I would say the most important thing about collaborating is to be open and to talk to people and enjoy it.
Yeah, Tina.
Related to that is, don't be afraid to cold email random people who publish something or write something or speak at a meeting that you go to, whatever it might be. We love to hear from students, and you will get a response. One of the things that's common that I hear among scientists and all faculty members, if a student contacts them, they're going to get a response faster than if another professional scientist contacts them. Yeah. This is why we're in academia, because we love to interact with students. So don't be shy.
Right. And one other thing to keep in mind is start your email with a compliment.
I love your work.
Yeah, I love your work. And continue. Yes, go ahead.
Hi, my name is Joe Yang, and I'm from Starkville, Mississippi. And my question is, in your view, what is the single most pressing challenge that interdisciplinary science must address in the next decade, and how can emerging scientists contribute to this effort? Thank you.
Okay. Oh, yes.
I'll try.
Okay.
What comes to mind is climate change, global warming, environmental impacts, energy needs of the world. World population is increasing. World economies are growing, and with that comes an insatiable appetite for more energy. But energy usage is at a cost. It has an environmental cost. So we really have to address this, and we have to address it quickly. I think the most pressing problems facing us in the next decades is really energy needs and associated environmental impact.
CK.
So this is a great question. And I want to comment that don't let yourself limit what you wanted to do. And for example, you may just mention all these big problems facing us. However, there are many other problems that you could look at, and sometimes unexpectedly solving one of these problems that you don't think is related could have large consequences. For example, the thing I wanted to mention is that you look at all the entrepreneurs, scientists, Nobel Prize winners, what have they invented? You thought, well, this is a science, this is not practical, but in the end, it could really, really benefit people that you don't really know it many years from now. And I should mention like quantum theory was way back, and now they're using it to build computers, sensors that could do something that we don't really know how to do before, and measuring very small, detailed phenomena that could, in a way, help energy, even mitigate climate change, and so on.
Yeah, one quick thing. Sure. So I want to expand on it. I think there are lots of problems. I certainly don't even know all of them. I'm going to tell you the latest problem I've encountered. And it really does not relate to my research at all, but it's something I'm now spending more and more time thinking about. And that's food security and nutrition. And what started me thinking about this is last August, I had the privilege of going to a country that most people probably haven't heard of and don't know where it is on the map, and that's Timor-Leste, or East Timor. And this is a country that, as many places around the world, is suffering from something I had never actually heard the name for before, and that is stunting. What it means is a lack of nutrition in the early years of one's life, so that in that country, the average, my understanding is that the average height of adult men is 5'2". This problem of nutrition is something that affects the whole world, but we don't actually know what the extent of stunting is in the United States because it's not measured. I am sure that it is here. I'm sure that there are areas of this. So nutrition, food security, being able to have enough food to feed the world is a really pressing problem. And the more people thinking about that on top of all the other things, I think is going to be very important.
Hi, my name is Mateo Camacho. I'm from Puerto Rico, and my question is for anyone on the panel. Failure is often a precursor to discovery. Can you share a moment in your scientist's journey when a perceived failure led to a significant breakthrough or unexpected insight that shaped your work?
Failure.
Very good question.
Have you got a failure moment?
I got one. I'll give you an example. So very early when I was setting up my scientific program, my independent research program, I needed to clone a gene. And everything in my project was dependent on being able to clone that gene. And at that time, there was no PCR, there weren't nearly as many technical tricks as we have now, and we were sort of brute forcing it. And I made a bet with my husband, who happened to be working with me in the lab. And we were going to try 2 different approaches and see who won. I lost. He won. I was thrilled because we cloned the gene. But on the other hand, I lost. Nevertheless, I had cloned a piece of DNA that was near the gene that I was trying, and I decided to sequence it. And I ended up discovering the central regulator of carbon metabolism in half of the species of bacteria in the world. I had no idea that that was what that piece of DNA was going to be, but just by chance, that was what I got. So don't give up on your failures. Sometimes your failures can lead you in completely new directions.
Cool. And anybody else? Yes, Umit. It's a good one.
I don't know if I can offer a specific incident, but what I would say is it's really important to be nimble in your thinking. Always question everything and always be ready to even question and change your hypotheses. There's always something to learn from experiments that don't work. It may not give you the result you're hoping to get, but there's still something to learn from it. So there's no such thing as bad data. It is data. If you look at it with a critical eye, there's always something to learn from that. So I think being nimble, flexible, and always looking at data with a critical eye is extremely important.
Just there's a wonderful line from the physicist Enrico Fermi that says, if your experiment confirms your hypothesis, you've made a measurement. If it doesn't confirm your hypothesis, you've made a discovery.
That's great.
That's a great one.
That's very good. Julia.
My name is Julia and I'm from Poland. I have a question for all of you. How can the scientific community improve the accessibility and in general, access to data? Thank you.
So the question is, some data is hidden behind paywalls, it's hidden behind agreements that companies make about not sharing data. There's so much data to be mined and understood. How can we make sure it's available to everybody? That was did I get that right? Yes, I'm close enough. I mean, it's particularly important, CK, I would think, for your work, because there's a lot of information that might be useful. I don't know, I'm thinking about, well, maybe Aramco. I mean, they may know things about underground geology that could be useful, but they may feel proprietary interest in not sharing it. I don't know. I probably shouldn't pick that example, but.
Let me relate back to the ChatGPT question.
Mm-hmm.
And you want to find whether it's fake news, you want to find whether it's fake data. And the only experience that I have is that you have to work on the data. You have to understand where it comes from, the physics behind it, the sensor that measures it. I could give an example which I ask naive questions in a medical exam. So they tell you, okay, your A1s, your blood sugar is certain level. So I naively asked the physician, what's the error? She said, there's no error. This is it. So I'm using this example to tell you all data has errors, and all physics are not perfect, primarily because we make an assumption on a physical problem and it gets basically updated. For example, Newton discovered the gravity, the law of gravity, and then Einstein would correlate it with general relativity. So to address the question of many data, how do you know it's true? So you have to dig down to the data, don't find a software. So I have experienced my students find software to process data, and this is it. This is not enough. You have to find the error sources and familiar yourself with the data.
Okay.
Hi, I'm Drew Paratia, and I'm from Plano, Texas, and this question is to anyone on the panel. With powerful new technologies on the horizon, how does one ensure that your contribution does not pave the way to initiatives with unintended consequences? Thank you.
Well, the law, if you find something that that you think is going to be a positive benefit and someone turns it into a weapon, for example, how do you make sure that your work, or can you make sure that your work isn't used in a way that you're not comfortable with? Did I get that? I hope it's close enough. What do you think? Is there any way, Tina? I'm not sure there is a way.
I'm not sure there really is a way either. I think it's important to always keep in mind the ethics that apply to your work or go behind your work, and make sure that when you're communicating your work, you're focusing on the positives and the directions that it can go positively. But unfortunately, once information is out there, it's very difficult to control how it's going to be used.
Yeah, go ahead.
I'm going to add a different perspective to this, and that is, I think after the development of the atomic bomb, I think many people like to go from scientific discovery to weapon. And it's sort of this thought of science, and sometimes they use that to prevent scientific discovery. And I think that's a problem. So I want to give you an example from GFP, which I described earlier. There's a guy named Bob Burlage originally from Oak Ridge National Lab, and he did a very interesting experiment. He took bacteria, put the GFP gene in them, but put that under an element that would control their production that was turned on in the presence of the explosive TNT. So if he had a petri dish that had some TNT mixed in with the agar, he would get these glowing bacteria. And you might think to yourself, why in the world would anyone do that? But what Bob knew was that one of the most horrible aspects of warfare are landmines, which are left in the ground and maim non-combatants, children, all over the world. And he wanted to find a way of detecting landmines, which he knew leaked TNT. And so he had a friend bury 5 landmines, disconnected. He's not a stupid scientist. And he came there and he sprayed the area with his bacteria and came at night with a handheld UV lamp, and he was able to pinpoint where the landmines had leaked the TNT. Now, to me, this really is an opportunity to really save people in the world, and I sort of really like his idea of being able to use this in a very unique way to maybe help people, to protect people. So I don't think that every invention does this. I should also mention that this is still a work in progress because one does not want to have a false negative here. So I know of at least 3 other groups that are working on this still to see if this could become a reality. But I don't think we always have to think about things going to disaster. They can actually go to helping people. And look at all the things that have been produced to help people. Think about, we've just been through this horrible pandemic, and the mRNA vaccines saved millions upon millions of people. Just an astonishing accomplishment, and so fast.
Okay. Lucas.
Hello, my name is Lucas Silva. I'm from Brazil, and my question is, what are your expectations for the new science of tomorrow? Thank you.
That's interesting. The new scientists of tomorrow, what are your expectations? Can you go ahead, Umit?
We don't even know, and that's the beauty of it. We cannot really predict what tomorrow's science will bring us, but that's the beauty of science. Discovering new things that we couldn't even dream of today. That's what's exciting about science. And we should never lose sight of that excitement. I think that's what really is important. I want to say one more quick thing, maybe in relation to the unintended consequences. Sometimes unintended consequences become apparent decades after a discovery. An example is Freon. Freon is a refrigerant. That's how we keep our refrigeration systems and air conditioners working, or it used to be. But then later on, we found out that freon depletes the ozone layer at the higher layers of this atmosphere. So do we say, well, it was a bad discovery because it really saved us, from food going bad, etc.? No, it wasn't. But now what we did was we found replacement for freon. So now we no longer use freon. There are other refrigerants which don't have that harmful effect. So don't be afraid of science. Even if it has some unintended consequences, science will find a way to fix it.
Any other? Yes.
Very well said, Umit. I want to give you a real example of accidental science. Some people don't like that term, right? So because we know what we are doing, we launch a satellite, we measure the ocean. It's called a satellite altimeter, which bounces laser or radar towards the Earth and receive the signal and measure the time difference if we know the speed of light. So this is devil is in details as how precisely we could measure something. So originally it was called CSAT. So they measure the ocean, try to do circulation. Some scientists say, wait a minute, can I use this data because gravity is actually adding, make the ocean go up and down? And scientists use this geophysical inversion theory to actually estimate the performance, meaning the seafloor, the details of the seafloor. So it's, to me, it's very famous in our field that this is accidental science. Nobody say, I launched this satellite, I want to do performance. No one did that.
These are all great. We've reached the end of the time we have. I want to raise one question, though, Marty, and I think the point you made about verifying things is totally important. But there is an element of trust that is involved, too. And I've done a lot of reporting about probes landing on Mars. But I've actually never been to Mars. And so I don't know how to verify that there's a probe that's landed on Mars. So there's this interesting interplay between, yes, verify, but also at some point accept that people aren't lying and making stuff up. My only comment. Can I ask everyone to join me in a round of applause for our panel, and we'll do this again someday. We're done. Thank you. Go out.
Our thanks to Joe and each of our panelists. And our presenter, Aramco. We are so grateful for your time and support of ISEF.